Hi.
My name is GUO from YUMIN Primary School.
I'm Protocol 11 years of grade 5, also from YUMIN Primary School.
Now we'll go on with method of limit calculating.
Method 3. Conversion of infinity calculation to infinitesimal calculation. So, this lesson first will revise our direct substitution.
Factorization.
So, direct substitution, what is
First
it actually?
method.
Yes, it is the first method.
Means like limit x approaches to something that just come in.
Okay.
In the determinable form always. And
Method 2.
factorization.
Factorization. Do you still remember that we have that pi notation?
Yup.
So, and the last part is a pi notation, right? For the first part of this factorization, it is actually
So
from one thing you just factorize.
yes, for example, all those a square minus b square a minus b bracket square a plus b bracket square dot dot dot.
Yes, correct.
Blah blah blah.
So for this time, which is the conversion of infinity calculation to infinitesimal calculation, it is that. What do we change it from? From what to what?
From infinity over infinity or any indeterminable form.
From infinity over infinity to infinitesimal over infinitesimal. So let's just take one example of this. What is this? What form? Is it determinable or indeterminable?
It is indeterminable form. It is
Which?
infinity over infinity. But let me ask you a question. Could we use the L'Hopital's rule? Is it infinity over infinity?
Okay, so
Maybe we could use the L'Hopital's rule. Could we?
so first way, what would you want me to use?
First, we'll use the method that we're using. The conversion between
The infinity calculation
infinity
to
to
infinitesimal calculation.
Okay, so the question is limit x approaches to infinity x squared plus sin x over x squared minus cosine x. And is the infinity over infinity?
So for this, what is the maximum of sine x?
1.
What is the minimum?
Negative 1.
Yes, correct. Cosine?
1.
Minimum?
Negative 1.
Yes, correct. So this, no matter how big it is or how small it is, it doesn't affect the infinity, right?
Yes, because infinity plus 1 infinity, infinity minus 1 infinity, right?
Yeah. So for this, the x squared is our biggest power, right? The
Yeah.
largest power. So from the numerator, denominator, we can
Divide the x squared.
so it will be like this. Am I right?
Yeah.
So for this next, you'll just sub them in.
Okay.
So a number over infinity, what is that?
Of course, a 0.
Yes, correct, it's a 0. So 1 over, so it's actually just like this. So it's actually just a 1.
Okay. So what about the L'Hopital's rule? Could we use it?
So you can try to use it. Remember, this is by L'Hopital's rule.
I guess this of course can.
Well, let's find out about that. So actually, the numerator, denominator, you differentiate them, right?
Yes. Still over infinity over infinity. Wait, can we just use another type of the L'Hopital's rule?
Try out then.
And we've got the answer, I think.
No, not so fast. We can only end here. There's no more others. We can continue. Because sine, we don't know what is their infinity, right?
Yes, and let me tell you. This need to be bigger or equals to.
Remember, for this sine x, biggest 1, smallest -1. So remember, negative 1 plus, right? Wait, remember 3. Because it cannot be bigger than 3, smaller than 1. Yes. Then after that, 2 plus cosine x. Same thing, right? So it do not exist.
But which are correct? Which are wrong? What? That one correct, this one wrong? What's the problem?
Well, this problem, first, when we look at the conditions, what are those conditions?
Well, we have the conditions. Infinity over infinity, continuous, and differentiable. Now what's the problem that is wrong?
So let me write these conditions out. So it must be a infinity over infinity or
A 0 over 0.
What is the other condition?
The other condition, differentiable and continuous. Okay, first try continuous also can. Because continuous is more important. Okay, so that's why we don't use n for n if it's not continuous. Because like only like 1, 2, 3, 4 like dot. Not like x which could be a straight line. Even though this is like
So for this,
bye mom.
do you still remember when we first learned pre-calculus?
Yeah.
We have the two types of conditions. What are they?
Infinity indeterminable form, continuous and differentiable.
What is this?
Sufficient
And
necessary.
okay, yes, the necessary or also the necessity. So these two conditions, right?
For example, there's parents who have 2 or more child. It's like the parent give a child $3 per day, but we are not sure which child is it. Because there's 2 or more child, so we're not sure which child. Then necessary. Sufficient is like Like for example, the same thing, but you particularly give to a child.
Okay, you gave out all the conditions to let you deduce which child is it, right?
Yes.
Or conclude which child is that, right? So this sufficient means you can deduce, you can conclude what is it, right?
But
How about necessity?
necessity, you give a child something, but you are not sure which child is it.
So basically, you cannot deduce, you cannot conclude what is that, right?
Yes, and what if both sufficient and necessity?
Both sufficient and necessary, well, when it is both.
For example, an adult and a child, definitely if the child parents, and the child parents must be the adult, of course. If those are the parents,
Okay.
I just random drawing.
So for this case, well, it is actually. What is that actually? Is it sufficient or is it necessary?
It definitely not sufficient.
So for these conditions of the L'Hopital's rule, it is necessary, not just sufficient, right?
Yes.
But how about the results?
The result, why couldn't be do not exist? What's the matter with the result? The calculation correct? So why wrong?
It's actually the method that is wrong, right?
Why?
Well, this method, remember, for L'Hopital's rule, the result must be unique.
Yes.
So do you know how to say it in whole sentence why this is actually wrong?
Other than the conditions, is still not enough. And plus, this is definitely not sufficient. It's not just sufficient, and it is necessary. Plus, the answer must be unique.
Yes, correct. So is this the only example that we cannot use L'Hopital's rule?
I don't think so.
Well, if you don't think so, can you think of any other examples?
You definitely trigonometry cannot. Can you give 2 examples? Because there's not just example like this that cannot use the L'Hopital's rule.
Can this be one of the examples?
Yes, I said 2 examples.
So can it be these 2 examples?
Yeah.
So these 2 examples, well, do you know why I only use sine, cosine?
Why can't you use the T code D? Actually,
Okay,
tangent, cotangent.
Tangent, cotangent, there is a line of singularity which cannot differentiate.
Yes.
Then do you know why I don't use secant, cosecant?
It cannot be from 0 to 1 or from 0 to negative
Oh, it
1.
actually also cannot differentiate.
Yeah.
So That's why I gave these two examples.
Even though we differentiate,
but you won't get the right answer.
yes, the answer is not unique. So, talk.
So, do you have any more other questions or anything else to say before we end this?
If you like our video,
Don't forget to subscribe to our channel.
okay.
So I will see you in the next lesson. Okay?
Okay. Stay tuned for more learning adventures.
Okay. Thank you for your watching.